All right, so we're down to the CISSP. By the way, tomorrow night, Caitlin is going to talk about the offensive security exploit development certification she got in the exploit development class. So if you're interested, I highly recommend that. She is a crowd pleaser, and there's a tech talk coming here, and all these things are worth extra credit. All right, anyway, we're in 125, which is CISSP, and we just finished the Net Plus chapter. So now we're down to chapter 5, which is Identity and Access Management. So this is standard CISSP stuff, and a lot of it is, in fact, in Security Plus. CISSP is sort of a souped-up Security Plus, really, with some management, which they don't have that much of in Security Plus. So you have to authenticate your people somehow. A question to be answered, do we need to turn in a topic? Yes, yeah, you're supposed to, yeah, I'm glad you mentioned it. Let me mention that. Yeah, you're supposed to turn in a topic. It just has to be, a few words. Yeah, in Canvas, turn in a topic. Some description of your topic for your paper, and that's it. That's for your next paper and your next presentation. Good? Yep, you should turn that in sometime tonight. Although I don't think my grader's actually punishing people for being late this semester. Anyway, it's good to stay on time. All right, so you have to, now identification is claiming to be somebody with a username, and authentication is proving it with something that most people don't have, and hopefully only the authorized user has. So most common technique is a password, just something you know. Something you have is another way, like a RFID card, or something you are, like your fingerprint or something. And another type is where you are, your geographic location. These are ways to, methods of authenticating who you are. Passwords are the cheapest and most common and the weakest. Static passwords are common. Passphrases are just whole sentences. There's one-time passwords that you can only use once, most commonly when you're doing a password reset, and then dynamic passwords. They keep changing all the time with something like an RSA token. So a static password, typically users choose them, and as we all know, they're notoriously weak. People are guessing passwords, cracking passwords, stealing them all the time. That's why people get hacked mostly. So it's better if you have two-factor authentication, not only your password and some other thing. That's much, much stronger. Passphrases are just long passwords with sentences and punctuation marks and spaces and stuff. These are much harder to guess, much harder, and if you choose good ones, they're fairly easy to remember. This is considered quite a bit stronger than using passwords. One-time passwords can be very secure, but you have to somehow be generating them. So you have to somehow have a list of these or some app on your phone generating them or something like that. And dynamic passwords, the most common type is the RSA that just changes every 30 seconds. So these are commonly used as a second factor of authentication. You could use it as your only factor, but mostly I see people using it as a second factor, which is a good idea because somebody could steal this object and you wouldn't want them to be able to get in by just having that object. So strong authentication is what's highly recommended for everything these days. Two-factor authentication, which means two different types of authentication, like a physical card and a PIN. Like when you buy something at the grocery store, you have a card and a PIN sometimes, although I never need a PIN for my credit card, so it's still single factor. So you can guess passwords. Passwords might appear in the log. You can tell when somebody is guessing passwords by looking at the logs and seeing too many attempts to get in. So they define a level for account lockout after a certain number of failed login attempts. You lock out the account for some period of time, and so on. Typically what people do in less highly secure systems is if you get it wrong 5 or 10 times, you're locked out for an hour, but then it unlocks, so we don't have to waste time making everybody keep going to the help desk to get unlocked. In a more secure environment, it would lock you out completely until you actually go in person with an ID card to prove you're the right person. So plain text passwords were stored on computer systems long ago, like 30 years ago, but that's a very unsafe system. Now they store password hashes. They run it through a hash function, and then when you log in, they run whatever you type in through a hash function and see if they match. And that way they can detect if you know the password without ever storing the password in a plain text retrievable fashion. You can crack password hashes, but the only known way to do it is to just have a list of guesses and hash all the guesses until you find a matching hash. So, if your password is on common lists of stolen passwords, it'll be pretty easy to crack. If it's not, then it'll be very hard to crack. They're either in the ETS shadow file on Unix systems, they're in Microsoft Security Accounts Manager in Windows. They're on, if you have a local account that you log into your machine with, which everybody has at least when you first log in, that's stored on your local system drive. In Windows domains, the domain accounts are stored on the domain controller. And actually, a copy of it on the local drive for that one user that logs in there. They're cached on there. And unfortunately, if your network administrators, if your domain administrators violate Microsoft best practices, which many of them do, and log in with high-privileged accounts on end-user workstations, then there are hashed versions of the domain administrator password on local workstations, which is very bad because they can be stolen by malware and cracked. This is why Microsoft has long, ever since Windows 2000 Server, they've told people not to do that. You should not be logging in as the domain administrator on an end-user workstation. You should be right-clicking and run as, and give the password once for one network action, and that does not store a copy of the password hash locally. But a lot of people are lazy and don't do that, so ever since, I think, Server 2016, you can now have siloed accounts which cannot be used on end workstations, but only on the domain controller. It is possible to technically prevent administrators from making that mistake, but a lot of people don't bother. Anyway, so to steal the hashes, you can steal the hashes from network traffic or read them from RAM or read them from the SAM file, and then you get these hashed passwords, which you have to crack by just trying millions of password guesses. And you'll see them here. Here's some common hashes. So if you hash the word password, here's various kinds of hashes. Notice the LM one, E5C2, and if you put in password with a capital P, the LM hash is exactly the same. This is what's used by Microsoft Windows up through Windows XP. It is case insensitive. It is very easy to crack. And yep, that's the problem. Yep, like most problems in security, these poor practices like logging in as a domain administrator on the endpoint are done by people who are in a rush and don't have time to be careful. So Microsoft finally quit using LM hashes and they upgraded to NT hashes, which are longer and they're case sensitive. So when you put a capital P, it changes, and that's what modern Windows systems use. The NT system, the stronger of the two, is only 1 million times weaker than what Linux and Mac uses. It's extremely weak hashing. All right, so the way you do it is the way you crack hashes is usually dictionary attack. You get a dictionary of stolen passwords like the RawQ database, and you just try them all. So to prevent this, people have password complexity and length rules to try to make sure that you're choosing a long enough and complicated enough password that it probably isn't in that list. Nowadays, a lot of people, it's an option now to use the, Troy Hunt has a list of all the stolen passwords, have I been pwned? And you can even automatically integrate it with your account creation system with an API, so when people first choose a password, it will check to see if that password has been dumped on a known list of stolen passwords and block it. That would be a good idea, but that's an option. I don't think that's built into any operating systems yet, although maybe it will be pretty soon. It's a pretty good idea. So, brute force, you try all combinations of characters. A lot of people also use this to refer to just using a huge password list. Anyway, it takes a lot of calculations, but you can do it a lot faster with graphical processing units. Back in the old days of Windows XP passwords, you could use rainbow tables efficiently where you stored a sort of a multiplication table in RAM. So by using more RAM, you could use less CPU cycles, and that was so effective that you could really try all possible passwords for those LM passwords in like 5 minutes on an ordinary system. Nowadays, rainbow tables are less common because modern, more complex hashing systems would require really a lot of memory, and it's less practical. Passwords should be salted, although Microsoft does not salt them. What's optimal storage when cracking passwords? Well, there are various systems. Yeah, you run Hashcat. What most people say is you don't really store anything. what you do is you use machines with GPUs. And by the way, I saw an article last week saying you can easily do it on Azure. Azure will provide GPUs. So you can make Ubuntu machines on Azure and give them GPUs, and if you give them enough power to cost like $10 an hour, they're really fast at cracking passwords. So you run Hashcat, yeah, you don't run it in a VM. You run it on the bare metal and you have GPUs. That's how you do it. That's the boss way to do it. And if you want to make your own hash cracking rig, I know Irvin has one, you buy some GPUs and make your own system. Anyway, it is a very good idea to salt the passwords. You take your password and add, say, 8 random characters to it before hashing it, and then you store those 8 random characters next to the hash. And the point is, if 2 users use the same password, they will have different hashes, and you won't be able to tell. This prevents rainbow table attacks, and it prevents you from spotting if 2 people use the same password. Microsoft has offered these password options in the security policy for decades. You can have a password history, so they cannot reuse a previously used password. You can have a maximum password age, so at this time they have to change their password, which is a government recommendation which they've now rescinded about a year ago, but most people don't know that. They're still forcing people to change their password every 30 days or something. And you can have a minimum password age to stop people from changing a password many times rapidly to get back to their favorite password, so you can only change it once every 2 days or something. You can have a length. You can have a complexity requirement, which forces them to use uppercase, lowercase, numbers, and symbols. They have to use 3 of those things. This is a very weak attempt to try to stop people from using passwords that are found in a dictionary, but in fact, the dictionaries of leaked passwords have every common password that fits these rules, so this complexity requirement does not really accomplish its purpose that much anymore. And here's something where you store passwords using reversible encryption, which effectively stores them in plain text, and it's been disabled in every version of Windows for a long time by default. You would only enable this to make it interoperable with MS-DOS or something ridiculous like that. All right. So users often write down passwords and put it somewhere stupid, like under the keyboard. If you were to put it somewhere safe, like wherever you store your $100 bills, that wouldn't be so bad. All right. So anyway, that's it for passwords. Type 2 authentication is something you have. So you could have a token like an RSA token, RSA Secure ID, or the Google Authenticator app. Then you have to have your phone or that token. Some of them are synchronized with the server. They just change every 30 seconds. Others are not synchronized, so you do something like press a button every time to get to the next one. Both of these will work in creating effectively a random number. And of course, there's the low quality one that's also quite common, where somebody sends you an SMS message with a number in it, which is a second factor other than your password. The only problem is SMS is sent very insecurely and not encrypted and pretty easy to intercept. So that's a weak second factor, although it's still better than having nothing but a password. So here's the asynchronous challenge response. You enter your username, the server sends you a challenge, you enter that PIN into your device, and then your token generates the response. The stories of people's Zoom video calls to sticky notes. Yeah, oh yeah, I've seen those. Yeah, even like government agencies on newscasts with the password just written on the blackboard behind them and stuff. Yeah. All right, then biometric systems. A lot of people push these and think they're going to be the answer to everything. They have an enrollment process, right? First, it has to somehow measure your fingerprint or whatever you're using. So you'll have to go through some process. I know when my Macs, I have to put my fingerprint down many times until it thinks it's got it. Then you have to have the time required to authenticate a user, which shouldn't be too long, or if the system will be not much fun to use. The accuracy of biometric systems is defined by these numbers. You have a false reject rate here, so you have a sensitivity control. If you turn the sensitivity way up, then it has a high chance of not accepting the valid user. It's too picky. If you turn the sensitivity down, then it will rarely reject the valid user, but you begin to have a high false accept rate, which is the chance of the wrong person being accepted. So to rate the quality of your device, you would take the crossover error rate, where these two are the same. The lower that is, the better your system is, the less errors. And you can choose what kind of security model you have. If you prioritize availability over confidentiality, then you would move over here, where you very rarely exclude the right person, even though you sometimes let in the bad person. And if you have a high security system, you'd turn it way up here, where you irritate your authorized users by rejecting them frequently, but you have a very low chance of letting in an unauthorized person. All right. And so fingerprints are the cheapest and most common. Now a lot of us have Face ID in the Apple phones and stuff, and there's many other ways to do it. By the way, none of these work by actually storing a picture of your fingerprint or a picture of your face. They extract numbers from the image and save that. So this is also how fingerprint matching works in court. They find these features, like these junctions, these peaks, and they record those. A retina scan is where it has to stick your eye in a cup and it scans a light off the back of your eyes. This is what they do at the eye doctor to see if you've got glaucoma or something. It is considered sort of irritating for the end user. It is not commonly used for authentication because people don't like to stick their head in a cup and have some kind of light shown into their eyes. What's far more common is an iris scan. This, you can just take a picture of you with a high-resolution camera, even from a distance away, and just look at the visible part of your eye. That's distinctive like a fingerprint, and they do not have to be invasive. In fact, they can even put cameras up in like the airport and be measuring these iris scans of everybody walking by and matching them against a terrorist list or do not fly list or something. So these are considered very good. Something a lot of people are pushing. Currently, they're expensive, though. And then there's hand geometry. I remember doing this at RSA 10 years ago. You'll stick your hand in a little plastic holder about 6 inches above some infrared reader, and it just measures something like the length of your finger or the geometry of the veins in your hand or something about your hand. So the end result is more or less like a fingerprint. Keyboard dynamics are to make you type something and just notice the pattern of how you type and how fast it is, how hard you press, things like that, so that the motion of your hand would be a biometric thing. Radiological signature, boy, I'm not aware of that one. What does the law say about notifying people? That's a good question, and I do not know. If you were to just put up a camera and measure all the irises and not tell anybody, I'm not a lawyer, but I would think if it was in a public place, you would not have to tell anybody anything because they have no expectation of privacy. But if it's in some kind of private building, then that's my first thought. But that would be up to lawyers to argue in court. It's a good question. Then you sign with the pen, and again, they can see, an airport, an airport is where you would want it. And it's a good question. I would just think from a PR point of view, you would put a sign up in the airport just to try to lower the customer complaints. But I think especially these days after the Patriot Act, you're probably under no obligation to tell them. But in fact, I think most people would tell you and expect you to feel more comfortable. I think, the TSA is not subtle. In fact, the TSA is arguably a government theater just to make people feel more comfortable. People would rather know that there is something being done to protect them. Aren't facial data reversible? They can't reconstruct the image of your face? Supposedly not, Mobo. Supposedly all these systems do not. The only exception is Facebook, and therefore Clearview, that takes real photographs of people online, and those are recognizable, and you can't erase them. And that's being used by. That's the problem. I think it's one of the many reasons why all the major companies have pulled away from facial recognition, where you actually store complete pictures of people. This turns out to be really a problem. That can be used for a lot of other purposes, and it turns out to be extremely inaccurate. I remember a version of it came out a few years ago, and they ran it on photographs of like the U.S. Senate and determined that like 20 of the people in Senate were wanted for murder or something because it was so inaccurate it would match your face with the wrong face. So everybody was pushing this until about 3 years ago. All the big companies like Microsoft pulled back and said they're not going to sell any more facial recognition products. They've turned out to be too dangerous. But there's one called Clearview or something that is doing it, selling it to police departments. It's highly controversial, mainly because it doesn't work. It's also extremely unfair. It's very much worse on black faces than white faces. So there's a discrimination issue too. Yeah, well, that's another thought, that some of the people in Congress are scary. But anyway, All right, and then there's voice print. This was the early one. I remember from the 60s and 70s. You just talk to the computer. It would recognize your voice the way humans do. For some reason, even though we humans can recognize voices, this turns out to be very hard to get computers to do with similar accuracy. So using voice print as authentication is still not caught on. And then, of course, we talked about face recognition. Passive but expensive. Law enforcement likes to use mug shots. Your driver's license has a picture. Many people have tried to use this. It was greatly pushed over the last couple of decades, but it seems to be not working out too well, where most people are now retreating from this technology. It's just making more trouble and not really doing much good. And of course, your physical location. If you find some kind of computer device, the IP address gives a general idea where you are. You might have a GPS, and therefore this is kind of handy. If somebody in a foreign country tries to make fraudulent credit card transactions, they can detect that they are not physically located in the nation that you expect them to be in, and that's a clue that it's a fraudulent transaction. So that's used by various systems, geolocation. All right, let's take a look at a Kahoot. 5A, right here. Something failed. Well, maybe it's going to work now. Looks like it is going to work. Okay. All right, maybe that's all we're going to get. Nope, okay. I'll wait another verse or two. Oh my, I definitely better wait. All right, I think we got everybody now. All right, so how do you make two-factor authentication? What do you add to a password? You cannot add something else you know. You have to have a different modality. Two things you know is not two-factor. So your IP address would be something about where you are. That's the only one here that's not a second thing you know. This is a common mistake. Something you know and something else you know is not two-factor. It has to be something you know and something you have, or something you know and something you are, and your IP address is a common one. This is why, like your bank will say, remember this computer? And then it won't ask you for the second factor anymore because it records your IP address. And said, well, if you're on that known computer, that counts as the second factor. Which it does, because the person who stole your password wouldn't be on that computer. That's the idea. Anyway. Yeah. All right. And what file contains password hashes on Unix? Oh, and by the way, beyond, it would be your public IP address is what the server would see. It wouldn't know your private IP address. Although technically those remember me functions probably use a cookie, which would in fact remember not your IP address, but that particular browser we're using, but it amounts to about the same thing. Anyway, they're in the shadow file on Unix. The password file does not contain passwords, and the SAM file is Windows, not Linux. All right, how do you stop a brute force attack? The online attack, where they're just making multiple guesses over the network. This is what Hydra does, the hacking tool. You stop it with a lockout. So if a person gets more than a certain number of guesses wrong, you lock the account. All right, what's the weakest password hash? LM are the really bad ones that even Microsoft won't use anymore. Microsoft upgraded to NTLM. All right. All right, what biometric system lets unauthorized people in? If you have, that's a high false accept rate, a chance of an unauthorized person getting in. All right. All right. I'm not sure who that is, but my grader might be able to tell. I do know DDD. And I know who that is. All right. Yep. Yeah, people had more trouble with that than usual, but anyway, this one part of the class that's on a curve, right? You just have to be at the top of the other students. Anyway, so access control. So once you've decided whether you're using passwords or iris scans or whatever, then you have to have some technical way of seeing if it's right. And the strongest and most common and best technique is centralized access control, where you have one device like a domain controller or a radius server that has all of it, so you can have the authentication done once for your whole network. And then you can have single sign-on, where once you sign on to one system, it lets you in a whole series of systems. And it can provide the AAA services, authentication, authorization, and accountability, which have been around forever and are required for enterprise-class systems. This dates from the days of the dial-up phone network, where it would keep track that you are a paying customer, who you are, and then record everything you do so they can put it on your phone bill. And computer logins have the same issues. It has to keep a log of who logged in and when they logged out, when they were on the system, and so on. You can have decentralized access control, where you have independent computers with independent lists of users, like home computers, and then you have local power, but the problem is then every computer is set up differently. They don't really have the same patch level. If you add a new employee, they don't have an account on all the machines, and so on. So this is not common at companies, but only, say, at homes, where you have a small number of computers. All right. And decentralized access control does not have an acronym, DIC. It's not that commonly referred to because you don't use it in companies hardly at all. Single sign-on, as mentioned, is very common. You have a whole bunch of different systems, and you don't want to make your users keep logging in over and over. So once they log into one system, that system passes a token over the network to say this person has already logged in, and you don't have to make them log in again. All right, therefore, this lets attackers steal that token and use it, and that's how token replay attacks work on Windows domains. It's a common flaw, pass the hash attacks. All right, so once you have gotten in, it would be good to have two-factor authentication to really make sure that you've gotten in, although a lot of people don't do it. Then an attacker can still hijack an authenticated session, like I said, by just stealing the token or taking over a machine after a login. So you should not let people walk away from machines that are logged in. It should be automatically locking with a screensaver, and users should be trained to lock their workstation when they leave their desk. So back in the days when people went to the physical office, you wouldn't have somebody walking by that can use your computer. All right, and then you have to deal with the old accounts. So when you, in fact, I had one of my dangerous hacker students kept hacking in my machine by using it when I walked away, and I actually tried to put on software that would automatically detect with Bluetooth when I walked away, but it didn't work very well. It's not easy to get your machine locked every time you walk away. Then you got the problem of what about when passwords change? Like if you make the passwords expire, which is no longer recommended, then you have to keep notifying your users and reminding them to change their password. Then you have to do something when people are no longer approved on the system, like a contractor that leaves. You have to make sure you have account revocation with human resources. And when people move to a different job in the company or a different location, you have to make sure and adjust their access rights correctly. And this is very commonly not done correctly. And there are a lot of news stories about somebody that gets fired and they leave and then hack in and ruin the system because even though they're fired, their account was not revoked right away, and so on. Another common mistake is people join the company, then they get promoted, then they get moved to another department, and you just keep adding more authorization to them, so now they have a bunch of privileges they don't really need anymore as they gain more entitlements, and that can lead to situations where they can defeat your other controls like separation of duties, where it should take two people working together to do something, but this person actually has credentials from both roles. Federated identity management is where you have one company that trusts authentication from a different company. And this happened to Microsoft, actually. I went to a talk about this. Microsoft developed Federated Identity Management servers, and their checks are printed by ADC like everybody else. So when students wanted to get their W-2 forms at the end of the year, they would log into their Microsoft account, and then they would go over to ADC to print out their tax records. But the problem is they had layoffs. So they laid off people at Microsoft, and now when tax time came, those people could not log in and get over and get their tax records. So, it's a problem. Now, in practice, the whole world seems to pretty much be using Facebook. Almost every site you go to will let you log in with Facebook, and that means they're trusting Facebook as the central identity authority. Log in with Facebook, Twitter, or Google is extremely common. One of the things Obama suggested was that the government would be your central management of identity for everybody. And it would be your internet ID, and then you wouldn't need to know all those passwords, and everybody was horrified, and he just sort of dropped it like he'd never said that. Because I think we all know the government, we'd probably rather trust Facebook than the government. And most of us would rather not trust either of them. Anyway, XAML is a language used to make security assertions over a network, like I have logged in as this person, I am the administrator, things like that. It's just a framework, and it's commonly used for single sign-on. It's used by City College systems and Canvas and many others. It's one of the many technical ways of passing authentication information over a network. So there's the issue of cloud identity, where you sign up for some kind of system, which is used just to identify you, and then you pass identification tokens to other systems. For example, Microsoft Accounts has this, and a lot of other systems that do. This is what Facebook has. You can log into Facebook, and then it will pass a token over to some other system, which says this person has logged in over here, So you don't have to handle the password. I took care of that. And they have approved for you to have, say, their name and address. So you can, that other server has access to your name and address, but they never saw your password. Anyway, so you can have, yeah, Okta. Okta's the big one. And I think Okta just got hacked. And that's why a lot of people said this is really rude. We got two-factor authentication through Okta. And now that Okta got hacked, it's going to be hard to convince our managers to do that. But anyway. Right, so then you got to have some way to remember the passwords for your individual users. So it's highly encouraged to use password managers. So people quit using the same password everywhere. So these will generate your passwords, store them. You just have to remember one master password to get in, and you often integrate with your browser, so it automatically fills it in. So it is highly recommended for everybody to get used to using password managers, and for companies to use enterprise class password managers so they can have an administrator at the company reset your passwords and things like that. Right. So you can have a third-party ID service locally if you want to. Instead of trusting a third-party service like Okta, you could host a server of your own to do this sort of thing, to be an identity server. And Microsoft has Federated Identity Management servers, and there are others. What's the difference between IDaaS, SSO, and Federated Identity Management? Identity as a service is just a term for the cloud provider that handles identity. Single sign-on is how you implement that on your network, where one sign-on is now accepted by several services. And Federated Identity Management is where a login at one company is trusted by another company. So they're all very similar, but slightly different. This is my old mentor who did this after being fired. I don't know. Oh, you got a link here. Well, let's see. Oregon Live. Oh, the Hewlett-Packard. Oh, this is one of the fired people that went back and trashed the network. Like I say, it happens a lot. Yep. Shut down their machines, got detention. Yep. There's a guy around here that went and got fired and then went right to McDonald's and hacked the system. And they had like his credit card receipt at McDonald's and everything. Yeah, this happens a lot. What a shame. And, if they had a proper offboarding process, I used to be the guy that did this at my company. I was basically a low-level network administrator, and they would call me on the phone and say, find Joe's account and freeze his account. And I would do that, and then they would call Joe and make him walk to the back and get fired. But before they fired him, they would call me and make sure he's locked out, which is the way to do it, of course. This is poor, management of human resources. They should lose their credential privileges when you fire people. Anyway, so LDAP is used to send information over the network to show who you are as you've logged in. It's used by Active Directory. There's a version of it that sent data by plain text that could be modified and spoofed. And there's a later version of it that uses TLS encryption to prevent that. Kerberos is an MIT system to avoid sending passwords unencrypted over the network. Instead, it sends these tickets over the network. And you'll always see questions about this on the CISSP exam, but you just need to know the terms. The Kerberos has an amazing number of components. The principal is the person using it. The realm is the network. Then you're trying to get a ticket, which is like a ticket to enter a movie, your permission to use the network. You send it credentials to the key distribution center, which then goes to the ticket granting service and gives you a ticket granting ticket, which you use to get a ticket to get on the service. It's ridiculous number of components, but it is effective. And so you send a session key encrypted with your secret key. You get a ticket granting ticket, go to the ticket granting service, and then you get a ticket to use the network, which is typically only good for 10 hours. So it is, Kerber roasting, all this jazz, all these crazy. It turns out to have a few weaknesses. Here's what it looks like. You wish to authenticate, you get a session key and a ticket granting ticket key. Now you wish to print a ticket granting ticket key from the ticket granting server. Now you get a service ticket, which gives you the ability to use something like a printer for 10 hours. It's kind of crazy, but it is what a lot of people are using. It is what you're using in Microsoft Windows domains. One of the many strange things about it is it's all time synchronized. Your ticket is only good for 10 hours, so the clocks must be synchronized in all the machines. If your clocks are off by more than 5 minutes, then it won't work because your ticket is only good for a certain time and the time won't be recognized as the same at the other end. Yeah, the diagram helps. Anyway, so there's a lot of weaknesses. The key distribution center has all the keys. If these servers go down, the thing stops working. You can replay some of these ticket messages over the network. Earlier versions let one person request a key for another user. You can crack these tickets and extract passwords from them with attacks sort of like hash cracking. It has various flaws, but at least you're not sending your password in plain text over the network. But there are attempts to improve it. So Sesame is a European system intended to be more secure, and the main thing it has is public key encryption, so it doesn't have these symmetric keys that are stored somewhere where they can be stolen from the servers. Radius is another really old system, so old that it's intended for dial-in users coming in with dial-in modems, and this would listen, and it was a AAA server. You could send up your password, it would see if the password was correct, then it would record when you logged in and what you did, so that's the game. The original one was UDP only, then it was upgraded to one called Diameter, and that of course used TCP. TakeActs is one used by Cisco, and then the upgrade TakeActs Plus, and the newer one is better, allows two-factor authentication and encrypts everything. So they all do the same thing. They just somehow store your credentials and tell you whether you're authorized to get in the network by taking the credentials over the network. PAP was the early system where you send your password with no encryption right over the wire, which is of course a terrible idea. So when people got tired of being that vulnerable, they switched to CHAP, where the server would send you a challenge. You would add the challenge to your password and hash it, and then send the hash up there. And that's better than the signal sent over the network is not equal to your password. Microsoft Active Directory uses domains, and it uses Kerberos. You can also have trust from one domain to another domain. You can have one-way or two-way, transitive or non-transitive, which is how you combine companies and like partners and acquired companies and such. You can decide exactly to what extent authorizing at one Microsoft domain would be considered approval at another Microsoft domain, which is a lot of the reason why people pay for Microsoft servers. They consider issues that are super important, like corporate acquisition. If I'm Yahoo and I buy AOL, Microsoft is there for you. They do have a system to connect those two networks together and allow the appropriate levels of trust back and forth between them, whereas if you were using Unix, you'd pretty much have to write all that stuff yourself. It's a huge issue. People do it all the time. And, Microsoft is there for you with that very common business issue when you have mergers and such. All right. And then there's general access control models. The general models out there are discretionary, mandatory, and then non-discretionary access control. Discretionary access control is the low security system for home users. You own a computer. You can just do anything with that computer. You can let anybody see the files, let anybody use your computer at your discretion. You own the object. This is what happens if you are the only owner of your machine, like your home laptop. But at work, you don't really want that, especially in a military environment. You have mandatory access control, where everything is, people have clearance and the objects are labeled like confidential, secret, and top secret. And now, you have to go to some higher authority and go through some process of deciding what your clearance is, and then some process of what clearance this information is, and then declassifying it and all that jazz. As you know, it's ponderous and expensive, but this is how you control levels of security, as opposed to just it all being at your discretion what you do with stuff. Non-discretionary access control is where you don't have the ability to do this at your own discretion, and there's two types, role-based and task-based, and the role-based is what you typically have in a corporate Windows domain, where you are sorted into a category like manager and sales and help desk, and then you get certain privileges based on your role in the company. So you have roles, and they have different rules. The basic user can do this, the auditor can get to the logs, the network engineer can get to the firewalls, and so on. And so they sort you into your job role, and that determines what you're allowed to do. Task-based access control is essentially the same thing, but you label people by what task they're performing instead of what role they have, which seems to be little more than just a different set of labels. And then there's the general category of just rule-based access control, where you just have some conditions, like only certain times you can log in, only from certain locations, firewall rules where certain kinds of packets can get in, but other kind of packets can't get in. They just logical rules to determine when access is permitted. And you can have content and context-dependent systems. You can have content-dependent systems that notice things like if you're an employee, you can see your own HR data but not some other person's data. You can have context dependence, like the time of day or the physical location, that determines what you're allowed to do. Just other considerations that would affect. This is defense in depth. So even if you have the right password and the right second factor token, it will still notice that something about what you're trying to do looks fishy. All right. So that's it. Let's take a look at the other Kahoot. 125 5B. All right. I'll wait a few more seconds because there were a lot more last time. They might still be coming in. Well, maybe not. Okay. Okay, what system accepts an identity from a different organization? Haha, no, there is no going back, Golightly. Yeah, that's it. Federated identity management. That's what they call it. Where you trust some other organization, and the fact that they logged in over there is accepted. All right. What happens on UDP 389? All right, that's LDAP, Lightweight Directory Access Protocol. Okay, how long does a TGT live? Yep, a ticket granting ticket lasts for 10 hours. By the way, there is something called the golden ticket at the root of a Kerberos tree that lasts for 25 years. And if somebody steals that, you have to rebuild your whole domain. Anyway, 10 hours. All right, what's the European improvement on Kerberos? Sesame. All right. Okay. On your home computer, what access control model have you got? That's it. Discretionary access control. You are the owner, and the owner can do anything they want. All right. All right. All right. All right.